What's up, Sarah? So this is going to be the 9th installment of my special series just for you. Hopefully you're starting to feel a little bit better. Your mom said that you took last week off, so now we're going to get back to it maybe this week. I'm in New Delhi right now in India. This is the last stop in India before we move on to Singapore, then Indonesia, then Australia, then New Zealand, then I'm back after Thanksgiving. So about 3.5 weeks, I'll be back. Anyway, enough about me. This is about you. So let's do some math stuff. I believe we took care of all the chemistry up through November 3rd anyway. So that being the case, we should go ahead and just at least talk about some of the math stuff. I did one math video for you. The other 7 were chemistry related. And what you sent me way back when, the end of October, was a whole bunch of line stuff. So how to graph them, how to draw them, how to get the equations of them, and so on. I think the first video what I did was I did the different forms of equations and stuff like that. So let's show you how you can get some equations of points. Okay, this will be a pretty quick one just to get feet wet, and I'm tired anyway because it's like 3 in the morning over here. So make this one quick, and then over the next couple days I'll get more in depth with them. So I'm sure you've graphed stuff before. I know last year was geometry for you, but I'm presuming back in 8th grade you had a little bit of graphing experience. So if you haven't, we'll slow it down, we'll go over it. But let's start off with this. Let's say you have 2 points, okay? Go ahead and graph this guy out. So you got these 2 points, -5, 6, and 3, 2. And you can probably see if there was a line going through them, it'd go like that, just like that. Now if I try to draw this looking at myself reversed in my own phone, it's not going to look as pretty as that. It's probably going to look more like, yeah, you see, but it was close. So let's say there's this line going, and I got to find the equation of it, okay? Or you got to find the equation of it, okay? Using just these 2 points. Now there's a couple ways you can do it. They might just give you these points, not even draw it for you, not even draw anything that I drew, and they just said, hey, find the equation of a line containing these 2 points. Okay? Let's pretend that's what they did. So all we do, if they say, hey, Sarah, graph the line that goes, or find the equation of the line that goes between these 2 points, the first thing you should do always is, if you don't have the slope of the line, how steep it is, the rise over the run, which could be a fall over a run. Now notice when I do that, I always say the run is to the right, okay? Because there are 4 directions here, up, down, left, and right. I'm trying to cut that in half to say only 2 directions matter, up and down, because you are always going to be going, as far as I'm concerned, and as far as you should be concerned, you're only going to go to the right. Okay, that means down to the right, like this line, should have a negative slope. Negative, you feel down, you feel negative, okay? Up to the right, you're feeling up, you're feeling good, you're feeling positive about yourself. Up to the right is positive. So just visually, we should get a negative slope here. Let's see if that is the case. Because we need a slope formula, and I'm sure you've seen this before, this is not anything new. But, and trust me, if you're finding that this is like, dude, I already know this stuff. I mean, this is like child's play kind of basic BS, I'm going to ratchet it up a little bit, okay, at the end of this video and in future videos, so don't worry, it's going to get a little bit more nasty, okay? So, in order to find the slope, first of all, you need the change in y over the change in x, because remember, it's rise, the y way, over run, the x way. And how that's written is a little something like this. y2 minus y1 over x2 minus x1, where all these y's and all these x's come from these 2 points, okay? This right here is x1, that right here is the second x, so I call it x2. y1 comes with the x1, and y2 comes with the x2. So I'll put those little markers down there. So we got x1, y1, and x2, y2. Pop them in this formula. Let's see what happens. So you can see all I did was I plugged and I chugged. I said that y2 is 2, goes right there in the upper left. I said that y1 is 6, goes right there in the upper right because that's where it goes in the formula. And then similarly with x2 and x1, 3 and negative 5. Got to remember to use parentheses around any negative number. It's always a good idea. Okay, so that's where it is. Now I just simplify. 2 minus 6 is negative 4. 3 minus negative 5 is positive 8. So I get negative 4 over 8, which reduces to negative a half. Okay, that's the slope of my line. Now, that's very important because you can go 2 directions from here. You can go 2 different ways depending on what form of a line you're asked for. If they ask you for slope-intercept form, this is what you do. Just pop in that slope to where the m value would go, because remember, slope-intercept form is y equals mx plus b. So the m gets replaced with what the m, the slope. By the way, why is slope m? I think I mentioned that in the other video. Who the hell knows? I don't know. But I'm sure you can Wikipedia it or Google it and you'll find out. At least, I hope that could happen. Anyway, the m gets replaced with the negative 1/2. And now I need an x value and a y value. An x value and a y value. Gee, I wonder where I could get an x value and a y value. I can get them from either point. I can't use the x from the first point and the y from the second point, though. I got to use the x and the y from the same point. So because these numbers are both positive and they're smaller, I'm tempted to use these. But then I'll look at the slope and I'll say, negative a half. I'm multiplying that by x. Is either of these guys divisible by 2? No, unfortunately, I made it stupid numbers, so I got to deal with it. So I'm going to pop in 3 right there. I'm going to pop in 2 right there. And I'm going to solve for b. So we get, where am I? 2 equals negative 1/2 times 3 plus b, like so. Now I'm going to multiply that out, and it just becomes negative 1/2 times 3. Or you can clear fractions. A lot of people don't like fractions, so if you want to clear fractions, all you're going to do is you're going to multiply everything by the only denominator that's there, 2. Okay? So what I can do is I can double literally everything. And that's what I get. Okay, I doubled 2 to get 4. I doubled negative 1/2 times 3 times 2. So that's like 3 times 2 is 6. Negative 1/2 of that is negative 3. And b doubled is 2b. Now I just solve it. I add 3. And then I divide by 2. And then I'm going to write my final answer. Viola, or voila, like they say. So I just solve for this. I get b equals 7/2 because I added 3, like I said. I divided 2, like I said. And then I just pop in that 7/2 value instead of b. I copied this exact same equation, replacing the b with 7/2 because that's what b was when I calculated it. Okay? So that is slope-intercept form. Now, if instead they say, hey, no, I want point-slope form. Remember, that's going to look a little bit different, but theoretically it's going to be the exact same. Because point-slope form is just this formula right here. Now, it's a little bit nastier of a formula than slope-intercept form, but if you remember it, it's way easier, so you should use it if you're given the option to use it, in my opinion. Now, you may think, no, this is ridiculous. I'm going to use slope-intercept. It's what I've always used. I like it. All good. You can do whatever you want. If you're unsure of which way to go, though, and you're not directed to use any specific form of a line, I say, you know what, point slope is great. Because it's just this formula right here. Y minus y1 equals m times the quantity of x minus x1. Where x1 and y1 could be this x and this y, or it could be this x and this y. It just means one of the points that you're given, or if you're only given one point, you have to use it. You plug the x coordinate of that point right there, and you plug the y coordinate where it says y1 right there. Y stays as y, x stays as x. Just like this had a y and an x in it, that y becomes that y, this x right here becomes that x right there. So I'm going to choose again 3 and 2. I already calculated my slope is -1/2, so check out what happens. I'm just substituting in 3 numbers for y1, x1, and m, and I get this. Okay, and theoretically this is the dead same as that. Okay, if I was to distribute the -1/2 and then add 2, trust me, I'm gonna get that. Okay, I promise you I will get that. Now let's say they wanted standard form. Okay, if they want standard form and you got to move from one form to another, let's say you're in slope-intercept form. Okay, let's go back here. Now, by the way, you can pause this video and copy this down if you want, because I'm about to erase this right here. Point slope form is gone, just so I have room to show you standard form. So remember, standard form is basically, in my words, you get x and y both on the left of the equal sign, you get the number by itself, the 7/2 in this case, on the right. But you got to remember 2 special conditions. There's 2 of them you got to remember. First of all, you're not allowed to have the x guy, the guy that leads off the expression, be negative. It has to be positive. Secondly, you're not allowed to have any fractions or decimals. And what do we got everywhere? We got fractions, right? So what I'm going to do first is I'm going to get rid of the fractions because they're very easy to spot. So the only denominator I have multiple denominators, but they're the same. They're both 2. So I'm going to multiply everything by 2, and I'm going to get this. That's just me doubling everything. I get 2y equals -x or -1x plus 7. Then I got to bring this x over to the left because remember, standard form says you got the variables on the left and the plain number on the right. So in standard form, boom, this is what we got. X plus 2y equals 7. Okay? X plus 2y equals 7. And then finally, if I wanted general form, I would just bring everything over to the left, including that 7. I'd subtract 7 from both sides, and I'd set it equal to 0. So that would be general form right beneath it. Okay, so we have slope-intercept. We had point slope here. I erased it to make room for standard form and general form. There we have it. So one other little detail that I want to mention to you is that that's great. It's easy to find, once you're used to it, right? It's easy to find equations of lines given 2 points or given 1 point. And if they give you the slope, all the better, because it's less work you physically have to do. You got to do this step first. But there's a couple things to make a note of. Okay, parallel lines matter, perpendicular lines matter. So they could say, I'm going to erase everything except for the equation in slope-intercept form of the line we got, which is y equals -1/2x plus 7/2. Boom, here we go. They can ask you a question like this. Alright, I'm going to get a wacky 2-step problem here just to close out this short video. Hopefully it's short, I don't even know what, oh man, we're almost at 15 minutes, I didn't want to do that. But, find the slope, why am I blurry? Shouldn't be the case. All right. So anyway, find the slope of a line. It's still blurry. What the hell's going on? There we are. Find the slope of a line, A, like part A, parallel to, and B, perpendicular to this line. And then, I forgot to write this down, but then they'd make you write the actual equations of the line. Let's say both of these lines, the parallel guy to this and the perpendicular guy to this, pass through the point 1, -1. Well, it's very straightforward. The first thing you do is you find the slopes of the parallel and the perpendicular lines. And the parallel ones are very, very simple, because the parallel line is the exact same slope as the line you're talking about. Because parallel lines, look, they never touch. That's got to mean they have the same slope, okay? So, for the parallel line, hey, slope of this line is -1/2. Slope of the parallel line has to be -1/2. Okay, very straightforward. And for perpendicular lines form a perfect T. You remember that from Schwartzman in geometry, right? So, all you do there is you say, all right, I'm going to flip and reciprocate. Okay, flip the sign, positive to negative or negative to positive, and do the multiplicative reciprocal of the fraction. Okay, so that means if the slope of the parallel line is -1/2, the slope of the perpendicular one has to be positive 2/1. Okay, I flip the fraction, I flip the sign. That's all I do to find parallel slopes and perpendicular slopes. Okay, but then we're trying to find equations of lines that are parallel to and perpendicular to the original. What does this do? Y equals -1/2 x plus 7/2. Well, if they don't specify what form it's in, remember what form I love to use the most, point slope form. And we have a point, 1, -1, and we got a slope in either case. So for the parallel case, all you do is this. Remember, it's y minus the y coordinate of the point you're given. So y minus -1, which is y plus 1, equals the slope I found of the parallel line, and then x minus the x coordinate I'm given. Boom. It's a lot of plugging and chugging. That's why I love it. Okay? And then for the perpendicular one, it's very similar to that. The only thing that changes is the slope, and we already know what the slope is. It's positive 2. So check it out. It is that simple, it is that straightforward. Okay? Unless it's not, which means unless your teacher asks you, oh no, I wanted standard form, or I wanted general form, or something ridiculous like that. Okay? This is the concept we're going to start with though next video. Okay, and we'll go through an entire example as if you've seen this video already. Okay? So, I hope you're feeling better. If any of this was too fast, let me know. If any of this didn't make sense, let me know. If you maybe try watching it again, or just rewinding it. You know, this is YouTube. You have the ability to watch stuff over and over and over again if you want. Not like a typical lecture. So, that's it for now. And I will upload this right away. And I will be back before you know it. I'll be back right after Thanksgiving. And in the meantime, I'll keep posting these videos to help you get back on track.